Okay, I wonder why my audio is doing that. Okay, I don't know what the heck is wrong with the audio today. Maybe that. Oh, shoot. There used to be a really convenient way to fix it. Okay, I'm gonna switch to that setting. Here. Okay. Won't mute now. Okay. But yeah, hello everybody and welcome to Universe Sandbox 2. Now, so obviously, in Universe Sandbox 2 we have the entire solar system and everything. And today we're really just focusing on we're in Universe Sandbox 2 is basically the creation and destructive end of things. So let's go to Earth and let's come up with a good way for it. So we need to slow time down a lot more. And I'm gonna turn off trails and labels. So one thing I have decided to do to the Earth is we can do one of two things with it. One thing that I know for sure we can do is we can fire something small at it. So I'm gonna use key number 1, and I'm gonna let's fire a few of those at the Earth. So I'm just using my number 1 key. So these little, so these Timoses are gonna collide with the Earth. Oh, it actually did do quite a bit of damage. Okay. Let's fire Mimas at the Earth. Especially it would do ridiculous amount of damage for its size. Especially in getting a lot of this, it would just skip through the atmosphere and just completely annihilate what was under it. But yeah, Mimas is going to leave an impact on Africa. It looks like we hit the western part of Africa. Yeah, so we're going to cause a little bit of a tsunami there. But yeah, that actually heated up Earth's temperature quite a bit. North America. So let's give the Earth a tiny bit to cool down, and let's find what has happened after a few years. Alright, so we have time-lapse to the year 2096, and what has happened over the last 100? Oh, so it actually wiped out a chunk of South America. North America still seems pretty normal, and Western Africa is just completely obliterated in the ocean now. So let's do something experimental. So if I go to tools, I can pretty much fire anything. We could do a laser, so I can literally left click and it does the laser trick. So I want to fix the radius. And let's make it a little bit smaller. So I fired a let's fire the laser. So let's just obliterate the Great Lakes, but I want to make sure that it's good. Let's obliterate Lake Michigan. We might actually burn the city of Chicago, but I really don't care that much. Okay, so now we have added our laser spots. The Earth is way too warm for water right now. Well, it's cooling down right now. It's at 300 degrees Celsius. But we just obliterated the Great Lakes, and if we go down right here, yeah, we are in the boiling lava. Let's go very close to the one in the Atlantic Ocean. Oh, you can actually see the place where it broke through in the clouds, so that's really nice. But again, when we're working with like stuff with this on Earth, we need to do something that's like a lot more realistic in comparison to this. So I do have a couple of ways where we can like cheat and like make this kind of work, but then again, I don't want to like do anything on purpose at this point. So last time I did Universe, well, I mean, I've already played Universe Sandbox 2 before, but one thing I learned about like doing this is that it not only is like really the destructive end of things, but it does have, but like it is crazy. So I have an idea. Let's turn Io into something special. So actually, let's actually do a grazing shot on Io. I'm gonna turn down the audio in my headphones just a little bit, because I don't want, so let's put it at about like, 40? Okay, so my Universe Sandbox 2 audio is at 40. We're gonna fire the moon at it. We wanna do a grazing shot, so I wanna make sure that I wanna control the moon's velocity. Now we want the moon to just pass by the Earth, and I'm gonna time lapse it so we can actually, okay, and let's bring the arrow velocity. And the question is, well, I mean, we're about to collide to Io right now, but let's see. So here's our grazing shot. And bye-bye, moon. Whoa! That actually... yeah. The moon's grazing shot just absolutely obliterated Io. Yeah, Io is not what it used to be like. Ooh, it had like a ghost face there. Oh yeah, that looks like a scary face. What's something that can easily destroy Io? I have an idea. So I'm going to switch to milliseconds. We're going to go about 1 millisecond a second. Actually, yeah. So I'm gonna go about 1. Alright, so there you go. 1 millisecond per second. Let's launch an object at the speed of light at the moon. So we can do a couple things. We can launch, let's see, we can launch an object. So let's make sure we choose wisely. Okay, let's modify. Let's see. Oh, I forgot to modify that. Okay, so the golf ball is... Oh. Okay, so let's... zero velocity IO. Oh, that's actually weird. Let's just put in a big number. Okay, let's put that in comparison to the moon. Okay, so we're still very, very, very small. Oh! That was unintentional. We gotta be careful here. So we can tend... Alright, so let's put that in comparison to the moon. How much does Io have? Oh, 2.3 moons, okay, so we'll be fine. Maybe we can time it. Alright, so the golf ball is at 1/10 the mass of the moon. So let's turn down the radius. There we go. That's going to work. Alright, so I'm gonna change its velocity. I want to make sure we miss over the entire thing. Now I'm gonna switch it to, let's go 1,000 times the speed of light. Oh. Forgot to turn that down. Here, let's go back to the solar system. So maybe in another video we can like destroy the entire system. Okay, let's go to Pluto. Let's pump so much mass into Pluto that it just instantly becomes a star. And Pluto, as much as I like you, we have to do this. It's for science. Science is fun. But as a lot of people say, science homework is not fun. But science is awesome. So I'm making Pluto very, very large. So I'm gonna zoom out a little bit. So I'm increasing the mass of Pluto. Also the radius of Pluto is increasing. Let's put that in comparison to the Earth. It's actually 29% the mass of the Earth. And it's at -231 degrees Celsius. When we reach about 1/1000th the mass of the Sun, which is about Jupiter size right now, Pluto will begin to pull itself together. And once it reaches 10 million degrees Celsius in the core, it will start to fuse hydrogen. It's gonna take a while, so let's put that in comparison to Jupiter. Alright, so Pluto is about half the size of Jupiter right now. Alright, so Pluto is the size of Jupiter. Radius is shrinking. This means we're getting very, very close to a star. But we're still, there we go, now we are a gas giant. So yeah, so the average temperature is increasing. It's at negative 150 degrees Celsius. Okay, it's above 0, and it's going to continue getting hotter. Now it started. Let's just keep adding. Oh, now it's got some. Actually, if you look at the top right, it actually has some pretty impressive solar flares. Okay, we're about half the size of the sun. If we times 2 that, boom! Okay, Pluto is the size of the sun. And let's see, if we time-lapse a little bit, let's see if Pluto has any effect. Oh, it actually pulled quasar. Oh, it actually pulled some objects, which is pretty impressive. It actually threw the sun off course, and it threw a lot of the stuff off course. And Pluto is not made out of light elements. But in order for Pluto to pull off the entire solar system, its mass needs to be bigger to pull this off. Oh, its luminosity is like really, really big. Oh, it's actually still got some solar flares going on. Okay, so its surface temperature is still the same. Let's look around. Now Jupiter is getting very, very attracted to it. And now Jupiter's like very orange because... Oh, it's actually still illuminated by the sun. Neptune is still in the neighborhood. But yeah, Neptune is out of the solar system. Let's just throw something at Neptune. I'm gonna throw a couple moons. I'm gonna throw a couple moons at Neptune. Just so we can see it. Alright. Let's see if these moons make it brighter. Oh, it's at 400 degrees Celsius. Let's go back to our star Pluto. I'm gonna see if Jupiter gets so attracted to it. It's at 380 times the mass of our own sun. Oh, Jupiter just got absolutely teared apart by that. Where's Sedna gonna go? Okay, Sedna is actually moving inward, so that's fine. Well, let's just keep adding. What's the worst thing that could possibly happen? Oh, we can make it like really, really big. Oh, now it's actually pulling in everything. Let's just time-lapse. Yeah, the entire system is being pulled in. I think the Earth and the Sun just got sucked in. Let's increase the surface temperature. Let's make Pluto the best star ever. There we go. Pluto is now a very active star. And now, there we go. Now we can see Sedna's surface features. And there it goes. And now we just have one primary solar system planet, Neptune. But it's still being sucked in. Oh, there we go. Now we can actually see its surface features. Everything is just going to be sucked into Pluto. Let's just disintegrate Pluto. I'm gonna find our explode button. Oh. I meant to create a supernova in that situation. But we can see Pluto is now a black hole. That's 15 times the mass of our sun. Oh, we can make the black hole like so. Okay, it is literally 6 times the size of our Milky Way galaxy. I pretty much broke the entire system because I just turned Pluto into a star and had that happen. Alright, so the last thing that I'm planning to do today is here we have the moon with us. Alright, let's look at a graph of the mass. So it's so at this point you can see the exact problem with making the moon larger than the Earth. It's actually at 5 degrees Celsius. So Earth is being sucked in. Here, if we go on, if we go on for the Atlantic Ocean, the moon literally fills 1/10 of the sky. The moon is now a rogue object. So the Earth is going to be sucked in. Let's just throw a couple of normal moons at it. This is the fun thing about it. Oh, I can only use the one on my... This is exercise. Well, like, even if it doesn't seem like it, just pressing the number 5 key. Alright, so let's throw a pause. The moon is going to cool down. It's at 1/10 the mass of Jupiter. Alright, so let's just allow this dust to clear. It's actually, the surface features are actually different and actually added some water and some land. We can make the moon a habitable planet. Let's just turn the water down. Oh, it actually has... Here, let's look at the overview. Oh, it barely has any water. Okay. So we need to increase the size of the water. There we go. Now, if we go to the surface, I think there's a way where we can, like, allow the moon to... What's the ability that allows you to, like, make it go faster? I forgot what it was. I actually, did this. Oh, shoot, I did not make me cancel. Here, maybe if I go to here, I'm gonna go back to the solar system one more time. Let's go to Palace. Okay. Let's throw. Who do we want? Let's throw. I don't have. Oh, we could throw rupees. At it. That was just something I created long ago. It actually ate Palace. Okay. Let's throw a few more. Alright, so I have an idea. While that is going, I'm gonna do a long-range snipe on the sun. There they are. Alright, so I'm gonna disable the launch. So we can literally go on the surface of the sun. If I can find down. Yeah. Alright, oh, because I was like, why did that happen? Astronomers weren't actually wrong. Pluto's orbit is actually closer to the sun than Neptune's. Sedna has an incredible 140 billion kilometers from the sun. Oh dear. Okay. Let's time scale so that the rupees actually do get moving. Let's look at these. Okay, so we gotta zero velocity every single one of these. At least one. So now it's gonna be sucked in. Well, it's gonna burn up as it enters the sun's sphere of influence. Boom! It just hit the sun. But the mass is so tiny compared to the sun. It actually does pretty much nothing. Let's look at the sun's rotational period. 26 meters a second. Let's lower its, let's actually increase its luminosity to 35 times. What would happen to Earth? Okay, so everything is normal on the Earth. Earth is at 314 degrees Celsius. Let's check Venus. Venus is at 552 degrees Celsius. If we increase the luminosity of the sun, 350. I know the surface temperature will change. Oh, the surface is actually showing itself. Yeah, the inner planets are actually burning up. Oh no, even the Earth is heating up, 835 degrees Celsius. Maybe if we can, I think there's a way we can get rid of all the carbon dioxide. But I don't want to destroy the Earth. Or we can move the Earth further out. which is also an option. But I think Mercury is burning too. Oh, Mercury is actually being cooled. Yeah. So, oh no, the sun is actually a blue star. Let's look at, the Mercury's got pulled into orbits around the sun. Mars is at 581 degrees Celsius. Is that water? Is that liquid water on Mars? No. I was actually surprised to see that if there was liquid water on Mars, I would like be freaking out. Jupiter, 205 degrees Celsius. That's normal for an outer planet. Saturn, 74.8 degrees Celsius. And now let's look at the ice giants, and last but not least, Pluto. Uranus is still minus 102 degrees Celsius, and it looks more blue, which is actually astonishingly cool. And let's look at Neptune. Minus 120 degrees Celsius. I'm gonna overheat the I'm gonna overheat the inner planets. I'm sorry, Earth, but as much as I like us, all humans on Earth, I have to do this. It's for science. Okay, so Earth is going to continue getting warmer. It's at 876. It's probably going to be scorched because I did it 10 times hotter. It's at 1,000 degrees Celsius, so I'm sure Venus and Mercury are like way hotter. Oh yeah, Mars is glowing. Venus is at 4,000 degrees Celsius and Mercury's at still at 1,000. Jupiter, 564 degrees Celsius, emitting some of the heat. Saturn, 344. Uranus, it's actually at 19.1 degrees Celsius, which is actually pretty impressive. If we potentially removed everything from moved everything from the Earth to Uranus, I know we would have like a different effect. But yeah, if we had like shifted life from Earth to Uranus, if the sun's luminosity was like, what's the sun's luminosity? The sun's luminosity is 3,500. I don't want to add negative luminosity, but what if the sun was like allowed this much luminosity, which is the total energy released every second? I know for sure that we would have like a lot different of effect on Uranus. But before I test out one more thing before I end this video, I want to check how Neptune is. Negative 35.5. Okay, so we're getting close. Maybe if we hit that times 2, it's probably gonna change it. While we're here, let's look at Senda. Hey, let me see here. What does Universe Sandbox 2 have the average temperature set at? What does Universe Sandbox 2 have the average temperature set at? This one's colder. Huh. I guess I'm not gonna answer that now. But yeah, oh my gosh, look at all of these objects. They are like orange. They're like yellow, blue, white, orange, yellow. I think maybe let's put the luminosity back to 1. Okay, everything is gonna cool down. So let's give them a little bit of time. Okay, so it's now the year 2039. The Earth is, the sun is still very, very blue, but we can fix that. I know the average universe sandbox true temperature of this is 5,502 degrees Celsius. That causes it to go white again. Now, it doesn't take very long for light to reach the planets. Oh, maybe it actually does. Venus is still really, really hot. Maybe we can, like, remove some carbon dioxide in it, and that way it cools down. Let's give Venus a long time to cool down. Okay, so Venus is still a little bit warm, but it's at 500 degrees Celsius, as well as other planets have recovered. Earth, oh no! Central America is pretty much gone. Greenland is still there. Here, maybe if I live here, we can look on this map. Africa is pretty much gone. Asia, Europe, the North Pole's still there. Antarctica, looks like Antarctica is still there. So that's very good. But I think that's all I'm gonna do for today. If you guys enjoyed the video, make sure to leave a like and subscribe. So yeah, this is Universe Sandbox 2, and I can't wait to do more videos. So yeah, see you next time. Bye!